you will learn how to manage DNS at scale in Azure. We'll start first by explaining the decentralized approach. We'll see its limitations, especially when it comes to large-scale networks, and then we'll explain the centralized approach and how it fits within the hub-and-spoke model. Let's start first with the decentralized approach, which means that in your virtual network, if you have here an application or a workload like, let's say, a virtual machine right here that wants to consume an Azure app service, and that Azure app service is exposed publicly through a public endpoint, you can actually disable that public endpoint, and then what you can do here is that you can create a private endpoint, and that private endpoint would have a private IP address, let's say something like 10.0.0.4, for example, within this network. And this VM or this workload can connect to that app service through that private endpoint privately if it knows that private IP address of the private endpoint. If it doesn't know that private IP, or it doesn't want to rely on a private IP, then here you can use the DNS names, where we go to here introduce a private DNS zone. We link it to the network, and then within that private DNS zone, we'll go to create a record within the zone itself. So the zone here would have the name for resolving the private app services. So it would have a name something like private link app services.net. And then because this app service would have a name, let's say, for example, app01, then here we would have another record that should be created with the name app01 concatenated to this endpoint right here, and that should go to the private endpoint IP address, which is in our case here 10.0.0.4. And then if I would have here a second record, let's say for example here app02, then I would just add another record app02 that will go to the other private endpoint that would be, for example, 10.0.0.5, for example, and we can show it like here in our architecture diagram. And this concept works the same way if I have some other type of services. So if I have a key vault, for example, then I would create a private DNS zone specific to key vault, and then add the A records for that key vault private endpoints. And the same way if I have AI services in Azure, or a storage account, or container apps function, whatever uses private endpoint, it would have its own private DNS zone name. So up to here, this model works very, very well. We should not have any issues about this, but the issue will start when we want to add another network in this architecture. So let's say here, for example, I have another virtual network here. Let's say that's VNet number 2. And within this VNet, I have also another Azure app service that in its own have here another private endpoint, and it would also have its own private DNS zone as this one here. So now if I have a VM at this level right here, to be able to resolve this private endpoint to access this app service. But now the issue will start if from within this workload or this VM, I want to resolve this app service that belongs to this other virtual network. So in this case here, we would have two solutions. One solution that is not really a solution because it does not work, and the second solution that is hard to implement. So let's start with first solution. You might think you can just go to link this private DNS zone to the other virtual network like here, create a link. But actually that does not work, because here it means that you are attaching two private DNS zones that have the same name. This one is for app service and this one is also for app service. That does not work. So actually this is not a solution, and we cannot implement this link right here. And of course that applies for this DNS zone to link it to this virtual network. We cannot do that. A second solution then would be to add the A records from the target virtual network. Let's say in our case here, this VM wants to resolve this private endpoint. So we'll go just, you might say, add the private endpoint IP address and DNS name to this private DNS zone. So that way you can have something here like app03, if we call this app03, and then you make a target that new private IP. Let's see, that's something like 10.1.0.4, for example. That way, yes, this virtual machine right here, it can resolve this private IP address. But the issue with this approach is that now who will create this A record? Is it this team responsible for this VNet, for this application, or is it the team responsible for this VNet? Because here in terms of operational model, we suppose that each team is responsible for its resources. So the application team here is responsible for the resources that it owns, and that application team will own this private DNS zone. So either it's up to this team to ask the other teams or to take a look at the infrastructure of the other teams, figure out what is the private IP address of that private endpoint, and then they add it right here, which is not ideal because that creates dependencies to the other teams. Or it's up to this team to go to add that A record to this private DNS zone, and that would be a violation of their access rights because they should not have access to the other team's private DNS zones. And this is an issue at a small scale. Imagine that now we have other virtual networks and we have other teams, like dozens of these virtual networks. Then that will create lots of dependencies between those different teams. So managing DNS at scale with this approach is not ideal. This approach is the decentralized DNS management. And clearly the issue with this approach is that here we might have multiple private DNS zones for the same type of service. That creates confusion and that creates dependencies between the different teams. So the solution then would be, what if instead of having multiple DNS zones, a DNS zone per virtual network, what if now I just can have one single DNS zone that will rule them all, and that single DNS zone will be used by all the teams and by all the virtual networks. And there we move from the decentralized DNS resolution or management to the centralized DNS management. Let's explain how that works. So now with the centralized DNS management, we would have actually a spoke, or the hub, and let's say we have the hub and spoke model, where here we would have the hub, and then within the hub you typically have the firewall, the main resource that would be right here, and then you have the different spokes that connects through peering to the hub. Let's say here we have spoke number 1, and then here we have another spoke number 2, for example. Now when you have, let's say, an app service in both spokes right here, and that app service uses a private endpoint in here, and this spoke also uses an app service with a private endpoint. Now here each spoke will not have its own private DNS zone as with the decentralized model, but instead it will be defined in a shared virtual network like the hub, for example, here, because it's already shared between all the different spokes. All the spokes actually can access to the resources within the hub. If we make the DNS zone available within the hub, this means all the spokes would have can get access to that. So that's one approach, but we have a better design. Especially here, we want to decouple the components that manages the connectivity from the components that manages the DNS. So within the hub here, actually, in addition to the firewall, you might have also the gateway for the connectivity with the on-prem, with the express route, with the VPN gateway, and so on. You might have a bastion also if you need to get connectivity to all the VMs from within the spoke. And you can add the DNS components right here from within the hub. But the better design would be actually to use another special type of spoke that would be a shared spoke. This shared spoke could be or could not be peering with the hub, and the idea with that shared spoke is that it will become the spoke that will use it for the DNS resolution. So this is the shared spoke for DNS. Okay, and the idea here would be just to use this spoke to attach the private DNS zones that will be needed by the spokes around the hub. So here we would have a DNS zone for the Azure App Service. So it would have private link appservices.net. And now all of these spokes, all of these app services will need to define their DNS name within this shared DNS zone. So for this app 1, for example, let's say this is app 01 that have private endpoint 10.0.0.4. It would have its own A record defined within this private DNS zone. So it would have something like app 01 and then private link appservices.net that will go to point to that private IP address 10.0.0.4. And the same thing for this app service 02. Let's say it have an IP address 10.0.0 or 10.10.4, then yeah, in its turn it will have a NAP02 that will point to that new, or to its own private DNS or private IP address, sorry. So all the DNS names will be defined in this DNS zone. That's the idea. Now, how can we resolve those DNS names from those different spokes? Here we have actually three solutions. The simplest one, you might say, is why just we don't get rid of this shared spoke and link this single private DNS zone to all the spokes. So this way, all the spokes will consume one single DNS zone, and all they will be able to resolve those DNS names. But again, that requires creating that DNS zone link to each one of those spokes. And if we have multiple DNS zones that are shared across those spokes, then we need to create multiple links. And we have actually a maximum of the number of the DNS links that you can create per virtual network or per DNS zone. A second solution, you might say, is just what if, as we discussed it earlier, we attach this DNS zone to the hub, and then from within the hub we have this firewall. If it's like an Azure firewall, it can act as a DNS server or a DNS proxy, and those spokes will rely on that DNS on the firewall DNS proxy to resolve those DNS zones. But that requires that each one of these spoke virtual networks change its own configuration for the DNS server, and those spokes will rely only on the firewall to resolve those DNS names. That might introduce some issues later for resolving domain names. A third solution would be to use, instead of relying on the firewall DNS proxy tool, we just use a custom DNS server. So you might implement here an Azure a custom DNS server within an Azure virtual machine, and because it will be injected into the hub or into the shared spoke where you have the DNS zone already linked, it will be able to resolve the DNS zone because it lives within the same virtual network where you have the DNS zone. But again, you need to change the private DNS server for the resolution in each of your virtual networks. The third solution would be much easier, and it's more easy also to implement because it's a managed solution. So with this solution, you would have like a managed custom DNS server that does not use Azure ES platforms like a virtual machine, but instead it would be a managed service. And this service is DNS Private Resolver. This component would be already injected within this network right here. So this means that it would be able to resolve all the DNS zones that are linked to this shared network, or we can also use it within the hub, but what's recommended is just to use it within the shared spoke. And then all of our spokes will be able to resolve the DNS zones right here through the DNS Private Resolver. How that works? Actually, we just need to add a link for the DNS resolver to the spoke network right here. So when we establish this linking right here, any workload right here like a VM would be able to get that private IP address through the private DNS resolver, and then it can use it to connect to this private endpoint. And that's the same for this spoke. For example, if it wants to resolve those DNS names, just go to create a link or get a link for that DNS private resolver. And with this solution, you don't need to change the DNS server for your virtual network. You just keep the default configuration, you add this link, and then you will be able to resolve this DNS as if it is already attached to your spoke virtual network. And that works at scale because we can create as many links as we want right here. And also, if I have another private DNS zone here, maybe because within this spoke I'm also using some AI services, for example, and I want to be able to resolve that private endpoint IP through a private DNS zone, then again I'll go to attach that private DNS zone at this level. In this case, actually we'll be using 3 DNS zones because AI services uses 3 endpoints. So we would have that name for private link cognitive-services.net, and another one for AI services, and the other one for OpenAI. And for that AI service, let's call it AI01, for example. It would have an A record AI01.private link then, and that will go to that private IP address. Let's say that's going to be 10.1.0.5, for example. And the same applies for here. And because this private DNS zone is attached to the shared spoke, if you want to be able to resolve that DNS zone, then we need to just add it to the DNS private resolver rules. Within the DNS private resolver, we have actually a configuration where you can specify what are the DNS zones or what are the domain names that could be resolved through this private resolver. So you would create a configuration here for that DNS resolver, and within this configuration you will say, hey, yes, I want to be able to resolve app service, the private link.appservices.net, and also the AI services, for example. Great. But now if you take a look at this model or at this architecture and the operational model, then you might see an issue right here, a big issue actually. So typically within the operational model of the hub and spoke, the hub and those shared DNS spoke would be managed by the infrastructure team or the network team. However, the spokes, especially with their workloads inside here, they will be managed by the application teams. That application team will create the service, will create that private endpoint, and when they do that, they will need to add their IP address of the private endpoint to that shared DNS zone. And they don't have access to that DNS zone because they don't own that DNS zone. It's owned by another team, which is the infra or the network team. So here they would have two solutions. One solution that is hard to implement, and most of the customers don't want that solution, which is just to go to create a ticket to ask that infrastructure team to create that record for them and then wait for a few hours or a few days before that DNS or name would be available for them. A second solution, which is more elegant solution and actually a managed solution, would be to rely on Azure policies. Azure Policy can react to most of those infrastructure changes, so it can detect that here, for example, at the subscription level or at the management group level or at the resource group level, that there is a new private endpoint created for this app service, and then that policy would be able to get that private IP address of that private endpoint and then add it to this DNS zone automatically. So this means that here we need actually to use a policy. We typically here attach it to the management group, because typically within the hub and spoke model, each spoke will live within its own subscription, and those subscriptions would belong to a management group at some certain level. So we attach that policy to the management group. That way it will be applied to all the subscriptions behind, and then it will be applied to all the private endpoints within this subscription. Then that policy will go to look for those private endpoints with their private IP addresses, and it will add them automatically here within this private DNS zone. And a small hint here, those Azure policies will run each 24 hours by default. So if you create your private endpoint here, you might wait for up to 24 hours. But to resolve this issue, you can actually manually trigger the Azure policy to run immediately after you create that private endpoint, and then within few seconds you would have that record created here without waiting for too long. So this way the infrastructure team or this network team will be very happy, because they will just create that Azure policy and will automate all of this work for them. Another hint here is that for this Azure policy to work, you'll need to create by default an Azure policy for each type of Azure service. For app services, for example, you will need to create an Azure policy specific for the app service. If you have Key Vault, you need to create one for Key Vault, another one for AI services, and so on. So this means that you will need to create multiple Azure policies right here. But because here we can create also custom Azure policies, we can create a custom policy that will handle all of those kind of services, all of those private DNS zones in one single Azure policy. And another hint here for using those Azure policies is that you need here to enable the remediation. That's mandatory actually, so that this policy would be able to use the create if not exist effect, which will go to create the DNS zone group within the private endpoint, and by creating that group, then this record will be created within the DNS zone. And to do that action, this policy actually will use also an identity, a managed identity that should have the right airbag rule, which should be in this case the network contributor, so that it can make changes to the private endpoint resource. So here we have discussed this model within the hub and spoke model, but the same architecture works also on when using the V1 model. where you still can define a shared spoke DNS and link it through the DNS private resolver to all your spokes. I hope this was helpful. Thank you.